Hello everyone. Today I would like to speak to you about Matlab. So I'll give you a brief introduction on Matlab, what is Matlab and how it works. All right, let's start this journey. Okay, so these are some of the resources that I'm using here for this presentation. So what is Matlab? First of all, Matlab is a programming language developed by MathWorks. MathWorks has a headquarter in Boston, and MATLAB started as a matrix programming language where people used it for solving linear algebraic equation and many simple other application like differential evolution. The nice thing about MATLAB, it can run both under interactive session or a batch job, so you can do both. The goal of this MATLAB course is going to be first, we would like to give you a gentle introduction to MATLAB programming language and design and give audience fluency in MATLAB programming as a second stage, and finally do some problem-based MATLAB solution, provide some solution using MATLAB and show how effective and fast MATLAB is in solving a diversity of application problems. So MATLAB can be used on daily basis, type of engineering and computer science application. For example, if you are doing some statistical analysis or prediction, forecasting, you can use MATLAB successfully to solve this type of problems. If you would like to do some control, UAV control, robotics control, or maybe automation or car monitoring system control, or system identification, or if you would like to do some kind of machine learning, because there is a very powerful tool books for MATLAB called machine learning, which includes tremendous search algorithm and technique. Also, MATLAB has a neural network toolbox, fuzzy logic toolbox, and many others. The nice thing also is you can execute MATLAB also on your cellular phone. If you go to Play Store and search for Matlab, you can download Matlab, which is like an exe file that link you to the cloud, the Matlab cloud. You still can do some operation on your Matlab. So this is very, very interesting. Um, Now, so outline of my talk, I'm going to talk about the characteristics of the screen that you can see in MATLAB, and we will try also to do some kind of examples on the MATLAB itself. MATLAB depends on handling arrays, matrices, and that's one of the very powerful application for MATLAB. When you cast the data as in the form of matrices, then you can manipulate these matrices in many different ways. And of course, MATLAB can do all the type of arithmetic operations, relational logic operations that like as you do in any other programming language. The display of MATLAB, by the way, in MATLAB you can create simply a very interesting graphical user interface in a very easy way. The flow control, like the if statement, the while statement, and so on, for loop, and then how you can write a user defined function, like any other programming language where you have like input and output attributes. On the right here, this is a kind of some of the graphics that you can create, like a layout or a grid or cross section of some of the functions that you can create using MATLAB. So MATLAB is a matrix laboratory, is a fourth generation high-level programming language, and it has been presented for a while, I mean maybe 1985, and it allows matrix manipulation functions and data plotting. By the way, plotting in MATLAB is very simple and straightforward and easy. You'll like it. You can do a lot of you can add to your plot like something like X label, Y label, title, grid, legend, all these kind of things. And also the algorithm implementation in MATLAB is very simple, and which is very essential if we talk about machine learning or data mining or meta-heuristic search algorithm or computational intelligence. So you will see some of these examples when we get to it. MATLAB is widely used for image processing. Yes, it's magnificent. I mean, in image processing, there is a lot of built-in image processing algorithms and filters that you can use with MATLAB, signal processing, and it is used for both academic and institute and research. So teaching and research is widely used with MATLAB. And another important aspect is it can be used for people with various background in science, engineering, and econometric. And if you search online, you'll find some books saying MATLAB for statistician, MATLAB for earth science, MATLAB for engineers, MATLAB for economics, and so there is many dedicated functions and application that makes MATLAB favorite for all these types of tracks or fields. So we will assume that you already have some prior knowledge about programming, just general knowledge. I mean, not really deep knowledge. I understand that many of you already know about Python. So if you know about Python, you will feel that there are some similarity in a way or another, and things will be much easier for you. Of course, we will handle variables, constant expression statement, and so on. If you have done programming in any other high-level language like C or C++, Java, then it will be very much beneficial, and learning MATLAB will be like a fun for you. All right? Okay. So from where the name MATLAB came, it's actually a combination of the word matrix, laboratory. So the first three characters of matrix and the first three characters of laboratory, so it becomes MATLAB. So it's originally a user interface for numerical linear algebra. It was commercialized in 1984 by MathWorks of Boston. Since then, it has been heavily extended. Also, for you to know that there are some alternatives or some other software which is available, like Octave, for example. It has same similarity as MATLAB if you just use the regular, MATLAB framework. But there are some toolboxes which is really not available on Octave. But you still can download Octave online and then utilize it for solving your problem as much as possible, right? And of course, there is Mabel and Mathematica as alternative. And of course, R is another language that can be used for this problem. And the reason we are using MATLAB is actually because there are lots of resources which is available already there. So you do which shows many meta-heuristic search algorithms that you might not need to build it from scratch. And I'm not sure if it is available in these other languages, but I'm pretty sure that it's available in MATLAB. So I really focusing here on not developing the algorithms step by step or line by line, but understanding how it works. That's why I am concerning here on using MATLAB for solving this problem. So some of the features that MATLAB has, it allows matrix manipulation, plotting of functions and data, implementation of algorithms, creation of user interface, interfacing with programs written in other language. By the way, that's also possible. You can do some interface with programs written in C and Fortran. So that's one of the very interesting features in MATLAB. So maybe if you are using a regular C++ program and you would like to utilize some of the functions in MATLAB, you can just link the MATLAB with C++ and execute the program the way you like. So it has numerous built-in commands and math functions that help you in mathematical calculation, generation of plots, and performing numerical operation. As I said earlier, I mean, MATLAB has many toolboxes, and these toolboxes have lots of routines or functions that you can utilize for your work. And the nice thing about MATLAB is that the core function of MATLAB is in C. So in MATLAB, you will figure out that many of the commands that you use in C, like fprintf, fscanf, and this kind of command, you can still utilize it in MATLAB. The nice thing also, if there is some problem or some case study or some command you would like to search, you would like to know about it, you can easily search online, write this command, and then say Matlab. You will find many resources and examples that's available over there that can help you. And by the way, one of the very interesting thing I like to tell all my students is you can write some LaTeX command in Matlab, which makes your graphics very nice. Your text on the graphs or figures are formally very nice. I will show you some of these examples later on, and you will enjoy it. So these are some of the features of computational like mathematics in Matlab. So Matlab can do all these types of application or operation. So we will try to discuss it as much as possible. Matlab is widely used as a computational tool in science and engineering, encompassing the fields of physics, chemistry, and math. On the right here, this is a kind of example of a layout for a system that was built using Matlab. But this system actually needs some more effort to do because it relates to something called Simulink in Matlab. We're not going to discuss it. More likely, engineering people are heavily using this type of applications. And in fact, you can create like a kind of oscilloscope or electronic circuit completely using Matlab and show the simulation step by step. All right. So Matlab can be used in many courses like algebra, physics, engineering, robotics, computer science, data visualization. And in robotics, really, there is a wonderful toolboxes of Matlab robotics. And as one of the interesting applications that you might want to check in Matlab is like path planning, robot path planning using Matlab. You can do it using some techniques like genetic algorithm, which is available in Matlab. You can do it with particle swarm optimization, which is available also in Matlab. And so the resources in this area can be, I mean, work successfully as part of a class project. Now, the Matlab environment is to set up a Matlab environment. You can use the Matlab installer. Right now, you can go online and install Matlab 2020B. And of course, the Matlab, you need a license for Matlab, but you still can utilize this for a certain period of time to use it. And as I understand, the package for student is maybe $50 or something, so it shouldn't be that much expensive. And you can go online and install it using internet. This is the link, or this is the screen that you will be getting when you try to install Matlab, and then the installation will take place. In this case, Matlab will be downloaded with mostly a good number of packages. Online also you can find some resources where you can learn Matlab online. So you can have a course online where you run Matlab on a cloud, and here is a link for this web page, and then you can select Matlab on RAM, or of course deep learning on RAM. So if you selected the Matlab on RAM, you can run or execute some type of Matlab commands, and if the system will give you an error message. You just need to register for have a username and password for MathWorks account, and that's going to be easy to do. So here you enter your email and your ID, and then the some of the details, and then you will get the account. Here, this is what's happening inside the course. For example, you have course overview. You have a way to show you how to enter command, store data in variables, use built-in function, building an array, and many others. So I encourage you, if you would like to try this, short course, that will definitely be great. Now, when you open Matlab, actually, you will get this kind of interface. And this interface will have like number of menus or screens. So for example, here you have the current directory content. So this shows the files under the subdirectory that you are using. And I want to tell you something which is very important. I always, tell my students that you need to create a folder somewhere in under your computer and save your files on that folder. Please make sure that you do that. And every time you start, you would like to run your MATLAB, change your current directory um, here. Make sure that the current directory is a directory where your files are. Okay, that's very important. Okay, so make sure that you are in this place, because you do not want to save your files under the MATLAB directory. And in this case, if you want to go and delete files, so maybe that will cause a problem to the Matlab itself. So please make sure that you are going to that subdirectory before you do any kind of computation or saving files. That's number one. Now here on the left, you have the current directory. So in that directory, you'll see all the files that you have. And here you can view a file. If you click on one of these files, you can see the content of a file. And here this is a workspace which shows a variable that already existing in the workspace. So these variables can vary based on the operation that you are doing. It can be an array, it can be a matrix, it can be a constant, it can be whatever. So this shows all the variables. And this is the command history. The command history will show what commands you have been writing down here in the command window. So if you, for example, you write CLC, so you clear the screen, you still have the command history here. All right, and here this is a help, and this is a toolbar, and this is a menu bar. So this is, by the way, this layout you can play with it the way you like. For example, for me, when I work, when I try to change my layout so that I have only the command window, and on the right I have the file, which is a file I'm working with. So sometimes I change this layout the way I like, and then I can save this layout. So every time I run MATLAB, I can utilize the way the layout the way I like. Okay, so this is an example of the current directory with some folders and the workspace, and this is a command window, and this is a command history, and so on. Now, so this is a separate file. So this is a workspace, this is a command window, this is a current folder. So I'm separating the files here to see the details. By the way, if you click on A here, for example, it will open like an Excel file which shows that A equal 23. If it is a matrix, it's going to be like a big matrix on an Excel sheet. Now, some of the basic operation that we can use on MATLAB is like you can use MATLAB actually as a calculator, and you can do any kind of operation on the command prompt, like addition, multiplication, taking a number to the power, and doing some kind of function operation like here sine by divide by 2. All these kind of things can be done in MATLAB command prompt, and this is basically you are using MATLAB as a calculator. Of course, some of the problem that you might encounter if you divide by 0, that this is going to be illegal, and this will provide infinity. So infinity is like an error. It's not an error. It's a variable, but I mean, again, this is, you don't want to do any computation and get infinite number, right? And here this is a multiplication. So you use a star to multiply variables, and this is the result. And this is e to the power 4. So this is like 1.486 times 10 to the power 4. It's like, this is the way we deal with it in MATLAB. Now, the use of semicolon, actually, if you use a semicolon after the command here, when you say x equals 3, so you are defining a variable called x and assign a value of 3 to that variable. So if you put semicolon, basically that will suppress the output and hide the result, but the operation will be implemented. So some people doesn't like when you run a big problem or program, you don't want to see the output comes out all the time unless you did it on purpose to see the result. So that's the only case where you would like to remove the semicolon. So that's something. There are lots of operators, as you can see here. I mean, some of them, we will talk about them step by step. Of course, you have addition, subtraction, multiplication. We have something called dot multiplication, and we have, this is multiplication operator. This is called dot multiplication. Dot multiplication is a way to multiply element by element. Let's say you have an array of values, and you would like to multiply the corresponding elements in each array. So not like regular multiplications. And this is to the power, and this is again to the power for dot. So for example, if you have an array and you say dot to the power, that will make every single element go to the power, and so on. Of course, parenthesis is very important and has the highest priority for the kind of operation that you are doing. And this three dots. This is like line continuation. So for example, if you are writing in the Matlab and then you feel like the line is long, you would like to continue on the next line, so you put the three dots and then you go to the next line, and so on. All right. We will see some of these commands and some of these operators while we are working. Of course, also you have logical operation like logic and, or, and not. So all these operators are existing here. You have bigger than, equal, less than, equal, and equal. This is a way that you can compare two numbers or two arrays or two elements and make sure if the answer is true or false. You can use it. Naming the variables. Remember that Matlab is case sensitive. So if you name a variable like, for example, small x, and then you call it as capital X, the answer will be wrong, or you will not find a variable defined as a capital X. So you need to be careful when you identify your variables. In some cases, when we define the variable, sometimes we use the first character as a capital letter and then the rest as a small letter. Sometimes if you would like to have like a long variable, maybe you can it consists of two names. So for example, you can have a first part and then underscore the second part. That will definitely be a way of naming the variables. Saving your workspace. Now it's very important after you do some kind of computation or operation that you can save your workspace. Okay, so if you have some kind of variables which exist in the workspace, then if you say save my file, and then what's going to happen, it's going to save the whole workspace immediately in a file with an extension called myfile.mat, M-A-T. Okay, then at any moment of time, if you, for example, exit from Matlab and then you would like to run Matlab again one more time, and then you can upload all the data that was before in your workspace by saying load my file. And this way you are not losing anything, especially in large programs where we have when we run a program, for example, for a few minutes, and we have lots of variables that was created from the run, and we don't want to lose this run for some reason, so we can save it. Let's say we can save it as save experiment 1, save experiment 2, save experiment 3, and then after we finish, we can check which experiment is better or is good, so we can utilize this result for our report or our research work. So here, as you can see, one of the very normal operation in C++, for example, if I would like to create a variable or identify a variable, we need to say, first of all, we need to identify the type of this variable. So we say it's integer, and then we name the variable here as age, and then we say equal to, and then we assign a value which is 20, and then we put a semicolon. This is how we do it in C++. In fact, this way of declaration does not exist in Matlab at all. And so you don't have to identify the variable as integer or double or float. Actually, Matlab accepts the definition of the variable just immediately, and he recognizes the type by itself. So for example, if you say x equals 3, now this is an integer, so it will be integer, right? And that's it. Okay, if you say x equals 3.0, so it will be a real, all right? So that's the way it works in MATLAB. There is no kind of declaration that will save you time and effort. Okay. Once a variable is entered into the system, you can refer to it later. Variables must have values before they are used. When an expression returned a result that is not assigned to any variable, the system assigns it to a variable named answer. Yeah. So for example, if you write like for example on the MATLAB command prompt, if you write 20, right, and then you say who, you will find something called ans, and it will return this 20. So here, for example, if you say square root 78, right, so the result will be 8.8318, and then a temporary variable will take this value, which is ans. If you did another operation, then the ans will take the new values for the operation. So this is like a temporary variable that exists in the memory. You can use it if you didn't assign this, if you didn't say, for example, x equals square root of 78. So that's the way it works. You can also do multiple assignment. You can do multiple assignment in MATLAB. For example, you can say in one line, you can say a equal 2 and then semicolon, b equals 7, semicolon, c equal a times b, and that will create the result, which is 2 times 7 will be 14. So that's, we call it multiple assignment operation. Now, on the left is operation that you want to implement or employ, and on the right is how you write it in MATLAB. So x minus y, so it's like this, x plus y, x times y, so it's x star y, x divided by y, so it's x divided by y, x to the power y, so it's x to the power y here, e to the power x, it's exponential, exp x, logarithmic of base 10 of x, it's log 10x, len x is log x only, log x to the base 2 is log 2, and then cosine x and sine x. So that's the way we, write this command out. Now, this also some examples of some kind of operation. Let's look at this one, for example, 2 plus 3 divided by 4 minus 5. So you want to separate the 2 plus 3 and put it in brackets, and then the divide, and then another brackets. Because if you did 2 plus 3 inside brackets divided by 4 minus 5 without the brackets, so 2 plus 3 will be divided by 4, then it will be subtracted from 5, which is not what you really want. All right, so brackets are very important here and has the highest priority for operations. So for example, if I say write a program that calculates and display the volume of a sphere when given the radius, so I would like to calculate the volume, so the volume is the output and the radius is the input. The volume calculation must be performed in a function called sphere volume. So the formula that we're going to use, v equal 3 divided by 4 times pi r squared. So r for me, if I say this is a model, so r will be the input and v will be the output. So we define r equal 0.5 and then say v 3 divided by 4 in brackets times pi times r squared, and then we get the output. Of course, this can be transferred to a function. I will show you an example of how can we create a function using MATLAB. This is a simple exercise or example of tank flow operation. Let's listen to it.
We're going to solve a simple engineering problem with MATLAB. We're going to first of all take our tank problem. Now this is a cylindrical tank, and it has a radius of 5 meters and a height of 10 meters. Now a volume of a tank with those dimensions is just going to be the cross-sectional area. So that's going to be pi r squared times the height. Okay, and then the volume of the liquid, that's going to be the flow rate coming in. That's meters cubed per minute times the time that is coming in. And in this case, if the volume of the liquid is greater than the volume of the tank, then we're going to say that it's going to overflow. Okay, so what we want to do is use the information of the radius, the height, and the flow rate, and then also the time. Let's just say that's going to be 120 minutes. Okay, so 2 hours. So after 2 hours, will this tank overflow? So let's go back to Matlab now. We're just going to open up Matlab and make sure you're in the correct directory here. You can switch which directory you're in and then click on the new script up in the upper left-hand corner. That will bring up a new editor for you. And the first thing that I like to do when creating Matlab scripts is just go ahead and do a clear all. So that will clear all of the variables from any prior work session that I may have had. And then let's just go ahead and define some of our values. Okay, so I'm going to say that's radius equals 5. It has a little message that came up that says that terminate this with a semicolon to suppress the output. So if you don't want it to show that value on the screen, you can put a semicolon after it. Now this is going to be the radius. I'm going to put a comment here just with a percent sign, and that's a radius in meters. And the height equals 10. Okay, and then the flow rate, that one is going to equal 15. Okay, and then I also have pi. I want to define pi. There's pi. Okay, and let's go ahead and first of all just do the volume of our tank. Okay, so that's going to be pi times r squared times height. Okay, so that was our volume of our tank, and then the volume of our liquid as well, and that's going to be the flow rate times time. Now when I put this in here, okay, so I don't have time defined yet. So let me do that here. Time equals 120, and then this one's going to be time in minutes. Okay, so this is the flow rate, and that's meters cubed per minute. And that is my height of my tank in meters. Okay, so now I have these two volumes that are calculated. Now if I want to just view that, I can just put it, just type vtank, and it will show me what the volume of the tank is and what the volume of the liquid is going to be. So when I run this, actually first of all I need to save it. So let's just name this tank. And I will save it as tank.m. Okay, and then when it runs, you'll see that the volume of the tank is 785 and the volume of the liquid is 1800. So it overfilled the tank. But let's go ahead and clean this up just a little bit. Okay, so I'm going to put an if statement here. So if the volume of the liquid is greater than the volume of the tank, okay, then I'm going to display a message. Now I could just do something like this, overfilled tank, okay, and then I can put an else statement here, and then tank not overfilled. Okay, so that can do the calculation for me, can evaluate the two to determine if it overfilled or did not overfill. Let's just be a little bit more elegant with this. Okay, so I'm going to put DISP. Okay, so go ahead and display this, and then let me do str. So let's do num to str. That's going to be a number to a string. Okay, and then I'm going to display the amount that it overfilled the tank. Okay, so volume of liquid minus volume of the tank. And let me just go ahead and close that. And by that amount. Okay, else the tank was not overfilled. I can also put that in a DISP as well, display. Okay, so let's go ahead and run this. And then if I come back to the command prompt, I can see the tank overfilled by 1014.6 meters cubed. Okay, so that showed me what amount I had overfilled my tank by. Okay, so this is just a very simple MATLAB program where I defined these variables, performed some calculations, and then used an if statement to determine if the tank overfilled.
All right, so from this program, as you can see, it consists of three parts. The first part is the definition of the variable. The second part is the computation. The third part is the way to display the output. So this is the way that we're gonna work with MATLAB more likely. Okay, but I just have one piece of comments here. I mean, in this program, I mean, you do not need to identify or define by actually. The reason is if you go to MATLAB, all right, so in MATLAB, let me just, this is the layout of MATLAB. Let me just go to layout and go to my layout, Ala. Okay, and then say CLC. Actually, in MATLAB, if you do by, you will find that by is already defined. Okay, so let me try with you, take you to a quick journey about MATLAB here and do some kind of operation. If I defined actually a subdirectory called my programs, so I take this location and then I go to MATLAB, as I said, and go here and insert it here. So now you are in the correct place. If you do any kind of program, save data or whatever, if you say BWD, it will give you the link to the program. So let me try to summarize what we have taken so far. So the declaration of variables. So if you say a equal, let's clear everything first. So clear all will clear all the variables, and then CLC. If I say who makes me see what if there are any variable in the memory. So here there is nothing here. Now if I say a equal 2 and b equal 3 and c equal a times b, right? If I do something like this, then nothing will appear because the semicolon suppress everything. But if I say a, I will find the value of a. If I say b, find the value of b. If I say c, I will find the value of c, right? And if I say who, now I should have three variables, which is a, b, and c, right? If I say whom, that will give me more details about each of these variables. So, okay, should give me, I'm not sure why it's not working, but whom should actually give you some insights about the variables dimension. I'm not sure why it's not working. But anyway, so this is number one. All right. Now, if I would like to define what else have we seen here? Yes, if we would like to do some kind of operation like define some functions like this. So we have the square root is defined. If I say w is a square root of 10, for example, now this will give me the result. If I say w equals, by the way, you can move up and down with RC. If I what I did is I use the arrow, so arrow can get me to where I want to go. This is all the command that I'm using. All right. So if I go down and so on. So if I say go like this and then I say w equal sine 10, so I will get sine 10. If I say w equals sine pi, see, it's almost 0. If I say w equal cosine pi, it will be -1, right? So these are some kind of the operation that to work with some, I'm going to talk about how to create a manuscript and a script and how to create a program. But let's go back again to the MATLAB. Okay, so oh, it's not whom, it's whose. Yes. So here, if I say whose, yes, whose. So whose gets me the size of the variable that exists in the memory. Whose, not whom. Okay. All right. So here we are. So who is a command that displays the variable that exists in the memory, and whose can display the variable currently in memory, the type of this variable, the memory allocated to each variable, how many bytes, and where they are complex or not, like complex variable or not complex variable. It gives you the class, if it is double, if it is integer, if it is, and so on. Now we have a clear. So by the way, clear can works with all, and clear can work with a specific variable. So if I say clear A, and then I say whose, so I don't find A. So I can clear one variable, or I can clear all the variables. Yeah, one more thing we talked about, which is if I say save my file or save my data, for example, like this, okay? Now, if I go to my subdirectory here, I will find some file called mydata.mat. All right, this did not exist before. Let me delete it again, delete, okay, and then try this command again. All right, here we go. So the file is created. Now let me clear all, and then say who again, there is nothing. Let's say whose, there is nothing. Now if I say load my data, and then say who again, so the data will come back to the workspace. All right, that's the type of simple commands that we talked about so far. So here, this is a variable assignment, so we can assign variable as we said before, and so on. Format, we can also play with the format of the variable. So we have something called format short and format long. I mean, these are the most common format that we can use. I mean, the rest is okay if you prefer some certain format to produce the output. So for example, if I go here and say format, now if you look at by like this, if I say format long and then say by again, you will see that I will get the long format. If I want to return everything as it is, I can say format or format short. If I say format again, this will return back as it is. All right. This is another way of doing format, something called format bank, which allow you to have only 2 decimal places. So I mean, you can play with this the way you like. You can check every single one of it, and of course change it the way you like. By the way, if you go to MATLAB here, if there's any command that you need more details about, so you can say for help format, for example, as a command, then you will get all the online description of the function that you want to see. Okay, so it gives you information about format short, format long, and everything, and also gives you some examples here. All right. Now, one of the very important, features of MATLAB is you can create vectors using MATLAB. So vectors are very essential in MATLAB. You can create a row vector, you can create column vector, you can create matrices based on these vectors, and so on. So for example, on the right here, I'm defining R as variable 7, 8, 9, 10, 11, and then we have another variable was somehow got t equal 2, 3, 4, 5, 6. Now R is a row vector which has 5 elements, and t is a row vector which has 5 elements. By the way, if you have a space between each number, that's fine. If you have a comma, that's fine. So both will produce the same same output. So there is not going to be a problem. All right. So let's see how this works here in MATLAB. Let's clear everything all. Okay. If I define a as a variable, say a equals 1, 2, 3, 4, 5, right? And b equals 2, 6, 6, 7, 6, 7, 8, 9, and 10, right? So if I write what is a, what is b, they are here. If I say a plus b, I will get the output right away. Okay. By the way, when we read the variables, as you can see, this is the first element of array A. So this is a of 1, and this is a of 2, this is a of 3, this is a of 4, this is a of 5. What one would ask me a question, what do you mean by a of, when I say a of 1, it's something like this. So it gives me the first element of a. I say a of 2, that gives me the second element. If I say A of 3, gives me the third element. If I say A of 4, and so on, right? So you can do the same thing for B. If I say B of 3, that will give me the elements of B, right? So this is a way you can read specific element of the array. And if you have A like this, right, this is a row vector. If you do A and then dash like this, it will be a column vector. So this is what we call the transpose. So the transpose convert an array of size. This size is 1 times 4 to, this is, we call it a row vector, because I'm sorry, 1 times 5, 1, 2, 3, 4, 5. So this is 1 times 5. So if I get the transpose of that vector, it will be 5 times 1, because we read the row first and then the column. Now let's do the same thing with B. B here is what? B is a row vector of 1 times 5. 1, why 1? Because 1 is the row and 5 is the column. If I say B transpose, it will be 5 times 1. All right? You can also do some kind of operations on the array. For example, you can get the min, the max, the mean, the maiden, the sort. You can find or search. Let's do some kind of this one. Let's say CMC. Now, sorry for that voice. So A, this is A, and then if I say min of A, that will give me 1. If I say max of A, this will give me 5. If I say mean of A, that will give me 3, right? So this type of operation, if I say sort, it's already sorted, by the way, right? It's already sorted. If I say sort A, it will be sorted. But if I define A as follows, let's say 2, 10, 4, 7, 20, something like this, right? And then I say sort A, now it's going to be sorted from lower to higher. All right. You can also define some empty arrays that you can use later on for some reason, right? So you have something called zeros array. So here you say zeros of 1 and 3. So this means that you are creating an array vector of 1 row and 3 column of zeros. If you say x equal ones of 1 and 3, it means create a row vector of 1 row and 3 column. All of them are ones. There is also something called random. Rand creates again an array. So rand creates an array of values which is all from 0 to 1. All right, all are from 0 to 1. Okay, so let me try this. So if I say r equal rand 1 and 10. Okay, so this is an array of 10 elements of size 1 to 10, which has values from 0 to maximum values, or the range of values from 0 to 1. By the way, one would say, why, Dr. Shetty, you are saying it's 1 to 10? If I say size, this is also one of the commands in Matlab. If I say size r, that will give me 1 to 10. All right? Everybody agree? Okay, now if I say E equal R transpose, for example, so R transpose, for example, then I say, what is E? Here is E. If I say size E, what should be the size E in this case? Yes, 10 to 1. All right? And by the way, it's not only creating an array, but also I can say grand, let's say 3 or 3 comma 3. Now this will give me a matrix, right? That give me a matrix of size 3 by 3. So this is the next step, is how to create a matrix. Now creating a matrix in Matlab is very, very easy. So for example, let's say clear all again. If I say A equals 2, I would like to create a matrix which has elements from 1 to 9. So it's going to be 3 times 3 matrix. So I say 1 space 2, 3 space comma, semicolon. So semicolon is what? Semicolon makes you go to the next line. And then 4, 5, 6, semicolon, and then 7, 8, 9, and then you close the, I will remove the semicolon, and then let's see what is A. So A is now a matrix of size 3 times 3. I can prove that by saying size A, it will be 3 times 3. All right? Is it clear? Okay, now also I can do the same operations on the matrix, which is I can get the A transpose. So the A transpose, what it will do, it will transfer all the rows to columns. So the first column will be 1, 2, 3. The second column will be 4, 5, 6, and the third column will be 7, 8, 9. So as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9. You know, the transpose, sometimes we need it for some type of operation. All right, so this is how we create a matrix. Yeah, there is one nice thing about Matlab you can do. So it's which is you can use the colon operation. Let's say for the colon operation, let's say I'm saying I would like to create an array which has like 10 elements, which are 1, 2, 3 up to 10. So instead of opening brackets and say 1, 2, 3, blah 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 blah, what we can do simply is something like this: 1 to 10, like this, and then the vector will be created. All right, that's so easy. Maybe I can do something like this. I can say 1 to 4, right? Like here, I can say 1 to 4 semicolon 5 to 8. This will create a what? This will create. So this is for element 5 to 5, 6, 7, 8. Yes, like this. So I can create a matrix this way. All right. Now also the colon, I can do something we call it step. So I can say t equals 1 to step, let's say step 3 until 15. So what's going to happen? So the MATLAB will create a vector which has elements start by 1, and every time I move to the next element, I add 3. So the first element will be 1, the second element will be 4, 4 plus 3 will be 7, 7 plus 3 will be 10, 10 plus 3 will be 13, and that's it. We will stop. Because if we add 3 to the 13, it will be 16, so it will be out of the boundary of so this is the start, this is the end, and this is the step. One would say, can we, Dr. Sheta, like make the step negative? Yes, you can say t equal 15, and then negative 3, and then 1. Now it will be vice versa. All right. Of course, some of the command like clear exit will exit MATLAB, and then global is very is a command that is very successfully used when we have like different functions and we would like to pass the values and make the value of some of the parameter like global, and maybe I can show it to you sometimes. You have change directory, date, delete, diary, and dir, load, path, BWD, which is we talked about display the current directory, save, type, if you would like to say the type, this will display a content of a file, and then what, and so on. So you can explore this type of operation by yourself. That's gonna need you just to try it. And then you have the display, as you have seen in the as you have seen in the video. So basically display a command on the screen. If I say display, this is my first MATLAB program, something like this, that will be displayed on the screen. Okay, so it's a way to display some text as a warning or as an output. Input is also very, very powerful tool. Let me just create a new script, or you can get it from here, or get it from here. You can say new script. Okay, so no. Okay, so first of all, if I would like to have this script, it's better to save it. So I can say save as, and then go to here and say program 1, for example, prog 1. And here I can say clear all. Okay, and then let's say, for example, I would like to prompt the user for an input to do some kind of operation. All right, so let's say, for example, I would like to say to collect values of some variable from the user, and then do some kind of operation, and then display the output. So I can say a equals input and then say enter the first number. All right, let me do something, make it a little bit interesting here. Leave some space and then take this one and then go down here and call this B, and they say enter the second number, and then so this way I can collect the input and then say calculate C equals A times B, and then say display C. Okay, so if I would like to run this program, there are many ways, by the way, to run this program. I can select this and then copy everything, move it like this. I can use run here, this, you know, triangle, green one, or I can write proc1 like this. So the program will prompt me for the value for A. So this will be like, let's say 12. The value for second number, which is B, let's say it's 45. Then the result will be 540, right? Okay, so that's a way of handling or entering variables for my program. Also, you can use fscanf and fprintf. These commands can basically help you to, you know, handle data output. I think I have some program here. If I say open file, this is read file, for example. This program, if I would like to open a file and write some variable on it, and then after that display the file, and then that open it for writing or for reading. So let's say I'm doing this command. Let's do here clear all. So this is a simple program. So if I say clear all like this, so there is nothing in the memory now. If I say then if I say x equal something like this, this will be what? Rand 8 to 1. This will create 8 random values from 0 to 1. And then when I multiply it by 100, then the values will move to what? Move to like 70, 80 or something like that. But the maximum value will be 100 because Rand will only create values from 0 to 1. So something like this. So as you can see, so Rand 8 to 1 creates a random value from 0 to 1. When I multiply it by 100, that will happen. Then if I say f open, so I will open a file called num s1.txt for writing, right? So when I run this command, I can, by the way, another way, if I highlight this, and I can highlight it and press F9, but I don't want to press F9 because F9 here will stop the recording, right? So then I will do that. If I do ls here, as you can see, I have here this is a working directory. So I have now num text. Okay, this file. This is I should say yeah. This file should be created here. I think yeah, it's here. Num text here. It's empty, right? It's empty. Now I need to fill it out. Now I say I'll take this. Okay. And then if I open the file one more time here, see, I have the values now. So I entered these values to, which is defined of this variable x, I filled it here, right? And I put this format for variable and then floating point, 4 floating point. See? So I have 4 floating point. Okay. Now if I say type num, now if I say type num, okay, then now I will see the output here. All right. Now, if I continue this running, okay, now this is output. All right. These are some of the commands. This is nice command, by the way. The reshape is a nice command that we can use here. The reshape actually can help you to reshape the values of one element or one variable. Let's say, for example, you have r equal 1 to 10, all right? And then if you say help reshape, that if you would like to see how help reshape, then you can say let's say y equal reshape. Now you have 10 elements, so I would like to put it in a form of a matrix, let's say 5 and 2. Then I say need to say R and then 5 and 2. Now I will get this. So I moved it to become like a kind of a matrix of 5 rows and 2 columns. I can do it vice versa, for example, 2 and 5. All right, so that's also possible. We can also create an M file where that's what we did. So when we created an M file, and this is basically an M file here. This is an M file, which is broke file. This is an M file we created. So you can open it at any time. This is a script. If I say open and then open broke file, the file will be here. By the way, you can play with this, you can move this way, you can move this way, and at any moment of time, you can change the layout, make it like 2 column, something like this. Okay, so if you say, I want to move this, you can take it and move it like this. And if you would like to close this, you can close it and have things like this. I like this format. And then you can say save layout, you can say save layout and save it the way you like. Okay. I think we covered most of the operations here, and I hope this is useful. One more thing here, how you can import data from a text file. You can say import data if the data is saved in a text file. So you can say import the data and then assign it to a variable, or you can also import data from Excel file and assign it to a matrix T and so on. All right. I hope this introduction is useful, and we're going to continue in the next section. Thank you.